Back with our last example, example 4, and in this one we've got a Corvette, a 2005 Corvette, and a table that shows how long it takes for a Corvette to reach each of those given speeds. So let's get this copied over here so we can take a look at it. And it looks like the Corvette is going 100 miles per hour just after 10 seconds pass. That's pretty good. So again, I'm going to hit my deal here and get my font to be bigger so you can see my work. And we've got everyone again. For this one, the X values, these values right here are not bad. So they're not huge, like years like 2030 or something. So we're going to go ahead and leave, in this case, this column alone because the numbers are not so funky that it will make our equation look crazy. So we are going to go ahead straight to inserting a graph. And we are asked for this, everyone, to figure out a linear and a logarithmic function to represent the Corvette's speed. So again, over to customize, down to series. We want a trend line. It's automatically going to put a linear one on there. And so we need to change label to use equation. So here is our linear equation. No, and not quadratic. This next time it's going to be logarithmic. So the linear equation is right there. And now this time we want to select, instead of linear, logarithmic. And so one thing interesting about a logarithmic compared to a quadratic is the logarithmic is going to come up and flatten out and stay flat. It's never going to drop back down. So the logarithmic option actually here looks like a much better option. So I think we are probably going to like the logarithmic option better. We'll put that in there. So what have we got? Which model fits the data better? How do you know? I'm going to say the logarithmic because look, it touches the points way better than it did if we were to be looking at the linear. So I'll pull the linear back up for a moment just to show that. Yep. And then the other piece is we know that logarithmic functions flatten out, and a linear function would just keep going up like this. And Corvettes are awesome, but they cannot continue increasing speed indefinitely. So if we went with the linear model, that linear model would predict that the Corvette would eventually reach 1,000 miles per hour, which is not going to happen. The logarithmic coming up and then flattening out at the top kind of represents the Corvette's top speed. And so this is definitely a better model. And then part C, how long does this model predict it will take the Corvette to reach a speed of 150 miles per hour? So I'm not even going to pay attention to the linear because I know it's no good. I'm going to use the logarithmic. We're going to slap it in here. And we're going to figure out how long it takes for this Corvette to reach a speed of 150. So it looks like this model predicts that the Corvette will reach a speed of 150 miles per hour in 40.4887 seconds. The logarithmic model predicts a speed of 150 in 40 point something seconds. 40.4887. And so that's part C. And lastly, we've got part D here, everyone. How fast does your model predict the Corvette will be going after 30 seconds? And before we do that, I'm going to see if this model predicts the Corvette will ever reach 200. In the case that it's not, we would get imaginary numbers. It looks like it is saying it could get to 200 in 145 seconds. Let's try 1,000. Let's see if this thing believes that the Corvette will ever reach 1,000 miles per hour. It looks like it does, but it's saying it would take forever. So even this model is not going to be totally accurate in figuring out when it needs to stop increasing in its value. We were looking for the model, how fast the model predicts after 30 seconds. And so we're just going to replace our X there with 30. I'm not sure if that's how Wolfram wants us to put it in there. Yeah, it is. So we're just going to, it puts the parentheses around the 30 for us. It looks like it's saying that after 30 seconds, the Corvette would be going about 138 miles per hour. That's pretty fast. So again, we can't, obviously the Corvette's never going to reach 1,000 miles per hour or something like that. So we have to, in every case, when working with these things, be realistic with the results that we are trying to find, everyone. That's it for example 4. I hope this was helpful, and I hope you have fun with all of these.